All right, hi. Yeah, I'm with you today as a disembodied head to celebrate Halloween and the zombies. It's kind of hot being disembodied though, so good afternoon or morning. It's morning for me. So anyway, anybody recognize these guys next to me? That is Sherman and Peabody, and they're next to the Wayback Machine. So I don't know, we'll get to zombies pretty quick, but in case, I just wanted to tell you a little bit about my background. I told you where I lived. And come on, James, get your screens together here. This eventually is going to go smoothly. Yeah, so there's the Wayback Machine. And when I was a young guy, there was a friend of mine who was programming, and it looked like a terrible thing. And so I was trying to avoid it. And then in college, in a calculus class, our professor made us program to simulate Newton's method for finding the area underneath a curve. And so we had to use one of these teletypes and write a basic program. And I found out, oh my gosh, this is not horrible. This is fun. And, people might pay me for this. So I got into it, and they gave me a data sheet, for an 8251 on my first day of work. So I'm an embedded systems engineer working with these ancient tools and programs stored on floppy disks and, whatever we could scrounge up in the forest to help. EPROMs that took a half hour to erase with UV light. So our cycle time was naturally kind of long. They took a half hour to program too. So doing something like TDD would not have been possible in those days. And sometimes somebody had to key in the startup in binary on one of these machines to be able to have a computer running at all. So kind of crazy stuff in the beginning. But we built some cool stuff. We built a weather radar display system, and the first of its kind in color. And then I got involved, so 20 of my years were spent doing something called debug later programming. You might have heard of it before. But when you start talking about test-driven, you need some way to talk about the other way, and the other way is debug later programming. And around 1999 is when I bumped into, I had worked with Robert Martin and an Object Mentor, and we had brought in Kent Beck, Ward Cunningham, Ron Jeffries, Martin Fowler to work with us to teach people extreme programming while we were learning. And so this was kind of an interesting thing to have happen. And Bob asked me, do you want to go to the Lightweight Methods Summit in Snowbird, Utah? And of course, I love to ski. And so, yeah, I'll go. And then, this Agile stuff happened. One of the striking things, one of the things that caught my attention in the beginning was Kent Beck demonstrating test-driven development to a group of people, running his code with no regard for where it was going to be deployed in a test environment. Now, I'm watching him do this in Java, and Java, of course, is different than C and C++ and other languages, but the idea of exercising your code in a test harness was just nothing that ever occurred to me in the first 20 years of my career. Debugging later and on target was the only thing we ever did. And then I'm seeing Kent doing this, and it's like, wow, this might be great for people doing embedded systems because we could start to get our code working before the hardware's ready. And you people that do embedded systems, you often are waiting for the hardware to be ready. And, so that's not a good thing. Now, one of the really kind of crazy things in the beginning was Kent would just say, get started, write a test. Well, what test would we write? And, Kent would be up there waving his arms, and Ron Jeffries, and they'd say, well, do the simplest thing that could possibly work. And, add one behavior at a time. This is different. We're used to writing function or numerous functions, class, and then getting it to work, right? And this is just focus on one behavior. Think of the tests that you need, and when you can't think of any more tests, then you're magically done. Oh, that's great. Do the simplest thing that could possibly work. What does that mean? Do the simplest thing. Add one behavior at a time. You're done when you're out of tests. This is very uncomfortable for a lot of people when they're getting started with test-driven development. And I help people learn test-driven development, and getting by their initial concerns is one of the big problems. And so where this talk comes from is from probably 10 years of me trying to help embedded systems programmers understand where the tests came from, up here. How did I come up with these tests and then this sequence and that sort of thing? And so the story today is about the genesis of that. And one of the things you'll be concerned about is if you're doing one behavior at a time, that your code's going to be incomplete until you can't think of any more tests. And that makes people very uncomfortable because they've had incomplete code before without tests. And so having incomplete code with tests, they don't realize that there's a difference there yet. Okay, so the test-driven cycle. And so people have been giving advice about this. Here's the cycle. You've heard red, green, refactor. I kind of put few extra steps in it when I describe it. Because working in C and C++, the compiler is a big problem as far as getting code to compile. And the tools, kind of primitive. So I kind of break the steps down a little bit further than someone else might. Write a test. It's not going to even build. And we're going to build it when we know it won't build, and we're going to see if it doesn't build for the right reason. And then once we get the code to build, then we're going to have rigged it so that it fails the test, because we're not going to implement anything except the necessary part from the compiler. And then we're going to make that code pass its test and then maybe clean up. And so here's the cycle. Now, Bob Martin has a similar set of rules here. Don't write any production code unless you have a failing unit test. And don't write more of a unit test than is sufficient to fail. Now, I take that one from Bob to mean, compiler, and the second half of the compiler failures are failures, right? We work in small steps and try to only have one thing wrong at a time. And then don't write more code than you need for the tests. And that will help you ensure that you'll have all the tests that you need. Well, all that you can think of anyway. And I hear from the newbies, people new at test-driven development, that it's really hard to stop writing the code. Like, you just could write a few more characters and that function would be done. Why can't I write that now? It's like, well, because you might not have, it might not be right, especially if there's conditional logic there. Right? And so we got to get used to this being incomplete until we run out of tests. I teach people test-driven development, like I mentioned earlier. Going through the course, after people get their first experience, I ask them some questions. And I used to ask the question, well, what did you think about test-driven? And then I would expect, some brave person, usually the person responsible for me being there teaching them, would say, well, it's going to help us have less bugs and have cleaner code. And then I'll just go, great, let's move on, because everybody gets it. And then on my way to one job, I was reading a book about how to get honest feedback from people. And you ask them a question, ask them specific, have them write the answers down. And so I started asking these 3 questions and giving people Post-it notes. What did you like about your experience? What concerns you about TDD, and what surprised you? And you can go look at some of the answers yourself on the links here in my website. You can find can you find those links? Well, at any rate, if you're interested in that, I'll send them to you. And people would fill out these Post-it notes, like getting the right tests is not trivial. These are real words from people that answered that question. Developers may not be able to think of a complete set of tests. I don't know what order to write the test, to do the test cases in. When should I stop writing tests? It's difficult to write tests that incrementally grows a solution. How can I be sure my tests cover all the corner cases? I don't know which test cases to write. How can I be sure I've got a complete set of test cases? I felt like I was careening from test to test, kind of out of control. And what if I overtest it? Can I write too many tests? Yeah, of course, we can write too many tests as well. How do I know when to stop? All right, so these are, given all these concerns, I would start to try to explain to them. It's like, we're trying to do the simplest thing we could possibly do, and, one behavior at a time, and, get used to it. And in the book, I wrote about 01N. And I asked Ron Jeffries, is there a name for this 01N thing that we're doing? And he goes, I don't know, 01N's good enough, or something like that, some conversation with Ron. And then I was talking to a friend of mine describing it to Tim Ottinger, and 01 many, he goes, well, that's 01N, that's 01 many. That's ZOM. And I'm halfway to the acronym at this point. ZOM, 01 many. Yeah, 3 numbers that we have to be concerned with in computer software development. There's 2 special cases, 0 and 1, and then there's all the other numbers which are not a special case. 01 many. It's like, okay. And so as I found myself describing people the reasons why I would do this relating to 01N and now having 01 many to relate it to, I also would have other words there. When I'm on these first couple of tests, the tests that I would call the 0 tests or the post condition to create, during those tests, I'm mostly concerned with the interface. So I'm at more of a design level, thinking about the interface, using the part of my software development knowledge and skill about interface development. And I would also be exercising a behavior. What is the post condition to create, right? We created an object, and is it in the right situation after creating it? Okay, so the post condition to create. And then we start exploring these boundaries and cataloging them in the test cases. And what happens next is, after 0 is 1, because you run out of the 0 test pretty quickly. Think of the 0 tests as if there's a thing that we're working on. We're going to work on a circular buffer in a minute. And the 0 tests it fits this problem very nicely because an empty circular buffer, a brand new circular buffer, should be empty, and it shouldn't be full. So those are two things I could ask it, and then I get those interfaces in place. I run out of tests that are meaningful after initialization pretty quickly. So what can I do to a circular buffer next to change some of the outcomes we might get? Getting from an empty circular buffer is a special case. What if I do a get while there's nothing in it, right? So there's those boundary behaviors we could look at. Now the one tests are also about interface definition and again, exercising boundaries. The boundary from a circular buffer that was empty and no longer is empty, right? So that would be adding the put method onto a circular buffer and adding the get method now to get that element you just put in and transition, again, the system from being not empty to being empty, exercising that edge condition. How do we make sure we exercise the edge conditions? By not writing code that doesn't have tests is one way. Exploring these boundaries in tests. Now, when we get to many, so we've exhausted the new interfaces and we've dealt with the simple edge cases, which many people would just ignore because how could we possibly get those wrong? They're so simple, and they're the ones that come back and bite us later. We move on to many, which is often the place where our brain is going. As soon as we hear the problem circular buffer, you all probably started thinking about wraparound and concurrency and a bunch of other of the special cases around circular buffers and the algorithm and the procedure for managing a circular buffer and the many case. But now we're ready for the many case now because we've put in place the interfaces that we're going to need once we get to the many case. And now we're exercising the behaviors of the many. And I'm going to go through a demonstration here with this, and we'll go through this and see us exploring the boundaries and the different, ensuring that our code is doing what we're supposed to do. When we think we're getting close to done or when we're done, we want to take a step back and think, what else is there? Are there error scenarios? Oh yeah, get from empty, put to full, out of heap, whatever it might be that are error scenarios in our situation that we have to plan for. So we think about those before we're done. And by describing this, keeping it simple the whole time, and keeping the scenarios that describe the system simple so that our tests act as documentation, keeping them simple and doing this all in small steps. There's a lot of S's involved here. Consider, while you're doing 0-1 many, that there's interfaces, exceptional situations, keep it simple, error situations to worry about. Okay, so there's a number of these words that kept coming out. And if you jumble them together and you start playing Wordle with it, well, that's 6 letters. Or is it 7? No, 6. You end up with zombies. Okay, now they're everywhere in that conversation. Not those mindless zombies, but this nice two-dimensional acronym. Two-dimensional acronym, I don't know if there's other two-dimensional acronyms around, but there's at least one now. 0-1 many. So over here on the left axis, where's my mouse? There it is. We have 0-1 many. While we're dealing with these, we want to consider keeping things simple. When we're on the 0 test, we're defining new interfaces, exercising boundaries, and the 1 case, defining interfaces. By the time we get to many, our interfaces are all defined, so we're not fighting the compiler for function declarations and all that sort of thing anymore. And before we're done, we want to consider the exceptional parts. Okay, so there's our TDD guided by zombies. It's the antithesis, so we're not supposed to think. It was hard to think. It's weird not thinking. People think we're not supposed to think when you're doing test-driven. It's like, no, thinking is essential. These are not mindless zombies. This is a very deliberate set of steps. Call your shot, if you will, deciding each step and finding the next best shot to take. So here, we'll use a circular buffer. We'll use an example here, a circular buffer, and we've got a series of integers and a module that manages the integrity of that, and the circular buffer rejects new values. It returns a default value. We might have some diagram that we worked up, while we're out at the pub. We wrote up these sketch on the back of a bar napkin on the scenarios we have to cover, and we'd think about the interface of the thing we want to do, and we would envision the solution to the problem. We're going to have a data structure which has a couple of indexes in it and the length, and we have a pointer to an array which might be allocated from the heap, and we're going to have some test cases that we have to concern ourselves with. And we think of these test cases, they're usually kind of high level, the things to test. We have to deal with wraparound, overflow, underflow. Is it empty? Is it full? Now, the happy path, what are the initial conditions? We'll come up with this list of tests to get started. If you find yourself guessing too much and stuck, then you have a good enough list to get started. And the reality of working on the CircularBuffer will reveal the other things that you should test, because you're going to come across scenarios that you might not have thought about initially. Let me go switch my view here. Let's just a little zombies here, a few steps of zombie-like programming, of test-driven development being guided by zombies. Let's get me out of the way here for this demo. I'll just disappear for a little bit, and we'll look at this. So here is our initial situation, and we've got, let me open this screen up a bit more. No, I didn't run the build yet. Let's see if my build runs. Oh, thank goodness it does. All right, there's a nice handy green at the bottom of the screen. And here is a test group. I'm using CPPU test, which is a test harness, which I'm one of the authors of. And I put a couple comments in here because this is a starting point of an exercise. I'm going to get them out of here because I don't need those comments, because I actually know how this code works. And anybody using a test harness after a couple of weeks, you're going to know these things too. And so having your beginner comments don't do you any good. You want to have meaningful comments as a skilled professional. So here is a setup function which creates a circular buffer that will be of size 10. And if you ask it for a value and it's empty, it'll give you back a minus 999. So these are customizable. And to make life easier, we try to anticipate the function signature and the needs of this so that I don't have to go through the pain of changing its signature later. I don't have any tooling to help me with that. I've been experimenting with CLion, and CLion's okay. It's got some capabilities here. It's not perfect in refactoring, but anyway, but I'm using Sublime Text. And during teardown, so setup is called before every test, teardown after every test, and here's destroy. And so this test says we can create and destroy one because teardown happened here. I'm sorry, setup happened there, and teardown happened there. So there's my first test. Now, thinking like a zombie, what are the post conditions to create? Well, a circular buffer, for one example, is not empty after create. Circular buffer is not empty after create. So that's our first scenario. And so we'd want to check something. And what are we going to check? We're going to check that the circular buffer is empty. When we ask it about the buffer, for the buffer, it would say that it is empty. Now, because this function doesn't exist, you'll see in the H file, I've got my simple starting point. Well, I have some comments in here because people doing the exercise, I want them to use particular signatures and such for the code so that I could run my tests against their solution. But at any rate, so here is the interface, which normally wouldn't be in here commented out, but it is in this starting point that I have. And then in the implementation, we just have our create and destroy functions, which we'll get around to looking at in a little bit. Now you're going to see that my skills of procrastination are highly honed. I can put off things that many of you would want to do right now. I can put them off till later, and it's a skill I've worked on. And I'm good at procrastination in real life, and so I brought that skill into programming as well with me. And so here I get a message from the compiler saying, this function was not declared in this scope. Well, yeah, of course it wasn't, and I expected that error, and that means I didn't do anything else wrong, like forget this semicolon. Let's see, does that detect? Okay, it doesn't know what they're missing. There could be other things I could have done wrong here, but I get the error that I expect. This is call your shot TDD, guided by zombies. And so I'm going to want this function here. And now if I run the build right now, and if this signature is written correctly, then I'll get a linker error. And let's see if we get a linker error. Yes, no, we got a check. Check. Oh, check with a small. Maybe some of you noticed that. Bad typing on my part, which I'm a pretty poor typist. Okay, now I get a linker error. Now, let me say something. Before I go into this, I'll tell you a little bit about circular buffer. I'm using an abstract data type. So in C, it's common to populate data structures in header files and reveal to the world your data structure. And then code that's so important that they couldn't possibly call your isEmpty function, just go look at the variables inside the structure and decide if it's empty on their own. And now you can't change the implementation of your circular buffer anymore. So I prefer an abstract data type, which does not reveal in the H file any of the members of circular buffer. We're going to keep that hidden. So this is kind of like, I came back to C from C++, and I'm trying to do the same thing as private, essentially hiding the implementation details, not making them accessible to the users of this thing. All right, so I've got a linker error, and as long as I've got a linker error, this function is probably, well, that signature is good. So let's paste that signature in here, and we'll turn this into a compilable thing. And so I'm kind of using a Python-ish naming convention here, and we're going to return. Let's see, I want this test to fail first. So CircularBuffer, if it's not empty, well, that should fail the test because it should start out empty. And so I hard code the return result. We're doing the simplest thing that could possibly work. And what do we get? We get a red test failure. CircularBuffer is empty. Line 34. Everything's working right to plan. That test failed right there. So now let's see if the test can pass as well. And now that often bothers people, hard coding a true value into the isEmpty function. But there it is, my test pass, and that means it's time for another test. Okay. Following Uncle Bob's 3 laws now, don't write production code. If somebody wants to go write that code right now because you're in that function, sorry, you got to wait until you're exercising it more fully. What else is true after create? Well, let's see, circular buffers, they should not be full. Well, unless, of course, they're empty and full at the same time. Now, I might want to make a note of that in my test cases, one of the abuse cases, to check to see if the circular buffer rejects a 0 size. Okay, but let's get back to the code now that we have an idea of what we're doing. So we want to do something similar here. And oftentimes these test cases are variants of each other. Now, copy and paste is a dangerous thing, you'll see. Is full, not full. Wait, James, you misnamed that test. Is empty after create. Okay. Is not full after create. Okay, so now let's run the build now. We're going to see that it doesn't know what this is full function is. And sure enough, the compiler knows that that's not the full function. And we've got so we invent a similar function for is full. We could watch the linker error here happen. And there's a linker error. Now we can go over to our C file. And this is almost the code we need at this stage anyway. So let's make a duplicate of that. And we'll call this is full. And, well, after create, presuming that there was a size provided, the circular buffer would not be full. So if I said it was full, it should fail the test. Oh, but it passes the test. It passed the test. Okay, so it passed the test. Copy and paste is dangerous. All right, now copy and paste without test is very dangerous because we're good at almost getting it right. Okay, on a good day, well, I used to think I was good at programming until I started doing TDD. On a good day, I've discovered in copy and paste that if there's n changes needed, on a good day, I get n-1. I usually forget one thing. And so, but now I know this about myself because in the past I could be ignorant of my weakness because the debugging happened so disconnected from the introduction of the bug, I didn't know where it came from. And I can definitely see copy and paste as a vulnerability, so I can be more careful now. Careful zombie at this point. So let's move on a little bit further. Let's fix our test case, right? We've got to fix that test case. So the test case is wrong because we forgot to negate the check. So we'll run that build again. Now my test fails, right? And now we can make it. Now this is full function. This is where people really want to code right away. And I've never seen anybody write the implementation of is full and get it right at this point of their programming. They always have to come back to it and go, oh, shoot, this doesn't work. So let's move on to our next test. Well, let's see. There might be one other test. I'm going to kind of skip that. There's a way to ask the circular buffer for its capacity, but I'm not going to bother with that. What if we put something in? Let's move on to the 1 tests. Okay, so 0. We exhausted our 0 tests, our interface defining tests. There are a couple more. I'm just going to skip them. So what are some of the things that we could do to a circular buffer to change its emptiness, for example? Well, we could put something in. So is not empty after what? Put, then get. Is not empty after put, then get. So here I'm going to start with my circular buffer. Put into the buffer the number 42, our favorite number from the UK. And because I copied and pasted, I better make that false. Now, funny story about choosing the number 42. Now that I'm talking to people who are from the land of Douglas Adams. I was in Japan doing this demo, and every time I needed a random number, I always picked 42. And after a day or two of that, one of the engineers came over to me and said, why do you pick 42? Did you play sports, and was that your number when you played sports? Or it's like, oh no, I've got to introduce Japan to A Hitchhiker's Guide to the Galaxy. So here's a book you need to read and find out why I'm using 42. At any rate, put that aside. Okay, so here we go. We've got a circular buffer put, which of course won't be defined, but I've got a test case that I think is right. If any of you notice me with a mistake while I'm working here, please feel free to let me know because I do make mistakes. And there is non-compilable code. It doesn't know what put is, so we'll go into our H file and we're going to define put. And now put can fail. Now, if it's the circular buffer is full, put can fail, but I'm not going to be dealing with the full circular buffer for a while. So even though eventually I'm going to want that to be a Boolean interface, I'm going to make it a void interface so I can ignore the return, because maybe I want Boolean, or maybe I want to return error code or something. Maybe there's several reasons to fail a put. I don't know. So I'm going to procrastinate the return type for now, and I should get a linker error. And there's my linker error. So we can grab this function body and bring it over to here where we need it. I can turn this into a compilable thing. There's my value that I'm putting in, and here is the reference to yourself. Data structure, oops, where'd that go? And because it's a void function, this should fail because I haven't done anything. And it does fail very nicely on line 45, and we confirm, call your shot. We made the shot exactly as we wanted it. Okay, so now I can think about the implementation. I'll probably want to look at this diagram that we had. There's our diagram. And so we're going to look at that first scenario. That's an empty circular buffer. Now, of course, it's memory, computer memory. There's values there. It's just that they're not defined, so they're showing them as gray. We've got an input index and an output index, and you can see that when the two indexes refer to the same location, that means it's empty. Great. Okay, so I've got an idea of how to start. And also, with the first time, they happen to be set to 0. Okay, so there's a couple of things I can use there, a knowledge of my code, to decide what to do here. Okay, so in the implementation. So in my implementation, I'm going to need the input index. So I've got this member, input index. I could call it head or tail or whatever. But among other things, I must increment that index. Okay, so it needs to be incremented. There's other things that need to be done. But for my current plan, if I increment the index, that's enough for me to tell the difference between empty and not empty. Okay, so if my input index is equal to the output index, which I don't have one of those yet, but I do happen to know it's going to initially be populated with a 0, so I can check it against 0, because that's at least correct for my current situation. And I can go to my circular buffer declaration here and add input index into the declaration. And now let's look at the create function. What the create function will do is a calloc, which you C programmers would know will allocate something big enough to hold this data structure. Now you can't see the whole code, so let's move my cursor out here a little bit. So it's going to allocate something big enough to hold a circular buffer, one of those things. And another side effect of calloc is to fill that memory with zeros. And if I remember all that properly, and if the code is really doing what I think it's supposed to do, I should get a passing test now. And there's my passing test. Okay, call my shot. Well, this makes me think of, I've got this hard-coded thing. So while I'm a zombie, I've got to pick the next test. And sometimes we get clues of what the next test should be from the things that we've hard-coded. And so here's some of the hard-coded things. And I'm going to pick one of them this time. And, a full circular buffer, I guess I could go into a loop now or put in several values. How many values would it be? Well, I don't know how many values to put in to make it full, so probably not ready to do that one. So let's worry about the isEmpty aspect first. So I'm going to go in, I'm going to add my test, which would be isEmpty after put, wait a second, is not empty after put. Why did I say then get? Okay, is not empty after put. Okay, is empty after put then get. I was getting ahead of myself, I guess. Is empty after put then get. So here's a put function, and let's also do a circular buffer get from the buffer, and now it should be empty again. Don't forget, I was about to push the test button, but I think I made all end changes now. I should get another compilation error because of the missing get functions declaration. Okay, got it. And I will go into the H file. And here we've got the get function, and let's just uncomment that. Now there's a return value here as well, and you saw from the test case that I'm not looking at the return result. All right, so here we've got the get function. It is an integer returning function, and in the test case we noticed that we were not checking the return result, so I could do a void function there as well, but my next test is probably going to look at that return result, so I'm not going to procrastinate this time. I'm going to define that to be int because I know I'm going to deal with the return type next, and nothing ambiguous about it. It might not be an error code. It's going to be an int. That's what it's going to be. So let's move back into the code. Right. And let's see. Did I get my linker error? Let's get my linker error. There's the linker error. And we'll grab the get function. Well, the get function is going to be kind of like the put function. So maybe I'll just borrow that put function and morph it into what I exactly need. So it's going to be an int returning function, and the name is get. It doesn't have a second parameter, and it's not going to increment it's never going to touch the input index. What it's going to do, though, would be increment the output index, but I don't have one of those yet. Let's comment this out for a second to get the compilable code. So we can return a -42. That's from the other universe where Scott Adams lives. Okay, running the build. I should get it. CircularBuffer put then get is empty failed. Check for is empty failed on line 52. And we put something in, we got it out. It should be empty. Okay, so there we go. Now we're going to introduce the output index. But some of you say, hey, James, if you just decremented the input index, you could get that test passing. But us zombies don't just do stuff to pass tests. Us people using TDD guided by zombies, we want each test to nudge the code a little bit closer to being done. And so I'm not going to decrement that, even though that passes the test, because that's really not giving me the opportunity to test an idea, which is I can use the input index and the output index to tell if I'm empty. So I want to experiment and get confirmation of that. So I'm going to introduce the output index. And I'm not going to decrement. What we're going to do is increment, among other things that need to be done later. And then here, we've got the output index being compared to 0. And then up in our, let's see, these should not be int. They should be size t. I'm going to leave them int for a second. I just realized I'm using the wrong type. Okay, so everything works just fine. So now I can use this to change to size t. And I'll change this one to size t. And it still passes, so that's a good thing. Okay, so what we've been doing is exploring the interfaces, capturing the boundaries. And I could keep going with the demo, but I think I'll go back to the presentation now. Oh, there's a crack in the universe there. Yeah, so there's some fun stuff you can do with the green screen. The real world's out here. Every now and then it tries to sneak in. All right, let's walk through. Okay, so here are the notes. We've got basically the things I've been talking about and a couple of the examples. Getting initial test to cause us to get the interface down, and building this walking skeleton. Okay, so not only do we get zombies and bodiless heads and that sort of thing, you get skeletons today. Okay, we're growing the behavior. Okay, so the skeleton so far is really just like the shell, the interface, how we interact with it. I can use this technique for more complex things as well and test out architectural ideas early. Like after I go through the 0 and the 1 of zombies, I've got one path that might work through the code that might be interesting to plug everything together to see how it works. And so I can start working on this walking skeleton. And I'm going to skip through a few of these because we did that. So at the point now where I'm stopping, what did we accomplish? Oftentimes this leaves new people to TDD quite concerned because I've got a bunch of hard-coded values. I'm calling it a CircularBuffer, and it certainly isn't one yet. But I'm feeling like I've made some progress when all I've done is hard-coded some return results and written some tests that are harder to fail than to pass. So what's the big deal? Have you accomplished anything? Well, yes, I think I've accomplished something. We have the interface. We've cataloged some of the boundaries, and we've got the shared data. We've got a view of how the shared data between putting and getting and is empty and is full, how they might work together, at least for the is empty case. When I was looking at this presentation, it's like, why do I have a robot here? So this is Robbie the robot from an ancient sci-fi movie. What is it, Forbidden Planet or something? A modern version of him. But the steps of TDD, I'm writing these tests. If there was a robot that could complete those tests, it would be quite easy for that robot to complete these tests. Okay. It's also pretty darn easy for a human to complete these tests because it doesn't take much to do with it. But if I had these tests, a robot could probably pass them. So ChatGPT could do that. Would that be helpful or not? It might be too much trouble because it's so easy for a human to do it. Could it help with the more complex tests? Well, maybe, although maybe not. One of the things us humans do as we choose test cases is that we are choosing the test cases that cause us to generalize. We start off with a CircularBuffer that somebody has only ever asked, are you empty? And, that CircularBuffer can be incomplete and just have one hard-coded return value. But as we grow its behavior, how do we get all these things that interact together consistent? And, maybe things like ChatGPT might help us one day. And maybe it could help on a simple problem like this. But, I'm wondering. I don't know. So what happens when we get to many, is now we're going to go into the algorithm. But I'm going to put this aside. This slide might be out of order. So the first of many, so now we're the first of many, and we don't have to deal with the compiler problems anymore, because we'll be putting things in, getting things out, and we choose a nice FIFO order here with pretty clear to see relationship between the 3 puts and the 3 gets, 41, 42, 43. We know it's FIFO. And we're relying on procrastination. And so if I look at, how could I do this? At this test, someone would be saying, I've got a circular buffer. I know that in the test case, we hard-coded the create function to say we want 10 values. So I've got to allocate something that holds 10 integers, and I've got to deallocate it. I keep saying the word and, meaning there's several things I have to do. So what I want to do first is fake it. Fake it till you make it. Why don't I just make a place that will hold enough values, hard code it, so that I can get the test to pass, and with the test passing, maybe I could refactor it into using dynamic allocation now that I have the safety of the test case in place. All right, so I might start this approach with just hard coding the values, the first of many. Fake it till you make it. Any of you TDD practitioners know all about that. So let's see, so the first test is our first kind of generalization. We're starting to generalize. It'll be hard again to ignore maybe the circular buffer is totally empty, or maybe it's full, and all these other things that we have to worry about. We're going to wait until we're on that test. So here's a diagram representing no neurological knowledge, actually, but just what it feels like to me to do test-driven development, and the 0 and the 1 of zombies. For starters, I'm having to deal with interfaces. I'm thinking about interfaces, about the capabilities. I'm really on requirements and design when I'm defining those first few tests, because I'm thinking about what does the interface look like. Now, immediately, I'm also struck with that part of my brain which has to deal with language syntax, which, they're related, but they're different problems. And the pickiness of C and C++, where the semicolons go and the asterisks, and, it's very, I guess any programming language is challenging, but C and C++, the compiler doesn't help any by giving you terrible error messages. But at any rate, and then the programming logic is something we'll get to eventually later. So how did you learn to program? Anybody want to tell me about your first programming experience? How did you learn to program? All right, so you didn't have anybody instructing you to say, here's how you program. Okay, so you, through your own school of hard knocks, you just went and figured it out. All right, anybody else have a different technique for learning programming? Yeah, okay. So here's a program. I'll paraphrase what you said. Here I'm programming. Here's a programming language. Here are some of the keywords. Here's how to print out stuff. Here's an assignment. Go figure it out, basically. Okay, that's pretty much everyone's path. Okay, now test-driven is actually a way to program rather than that amorphous thing, which is go figure it out, which of course we love to go figure it out, because I was shocked. Someone's going to pay me to solve puzzles? I mean, when I'm not programming, I'm playing Wordle or something, or playing cards, or, trying to solve some problem, solve some puzzle. All right, so your paths were similar. Now, in TDD, there's a state machine. And of course, us embedded systems developers love state machines. And so here's a state machine on programming. Well, think of a list of tests, pick one, write the test. It's not going to build. Get the compiler, tame the compiler first. Then it won't link. Then make it link. You might have to tame the compiler some more while you're making it link. Now your test fails. Now make it pass. Did you make a mess? Clean up. Pick another test. Keep going until you run out of tests. All right. And so we have a systematic way of working, which is, I think, a huge breakthrough. Because in the past, when you have something as simple as a circular buffer, if we finish this example, we'd have probably not quite 20 tests. I think you end up with about 16 or 18 tests when you finish the circular buffer. That means there's 16 discrete things we have to keep track of to be correct. Now, how many problems are you good at solving at any one time? 18? 16? Wait, 1? Yeah, 1. Yeah, we're usually better at 1, not at 16. And so what's cool about this is as I'm working through, if I get interrupted, I can just pick up where I was, because I'm on something small right now and it's part of a long train, and I can kind of see the part of the train I'm on and get back on, right? So I've got a way to be successful. Here on this circled part now, that's when we're using part of our the 0 and 1 part of our brain where we're dealing with the compiler and the linker. Okay, so I'm sorry, yeah, during the 0s and the 1s of zombies, we're dealing with the linker, those tests, right? And so I've got my interfaces and design, and I've got to deal with my programming syntax. This animation was supposed to be on the other slide too, but I only put it in one place. Copy and paste error. Now here, over on the left side, is where we're engaging our solving the problem, the application problem now. With CircularBuffer, it's how do we make this FIFO that's reliable, etc. And then refactoring, how do we keep it clean so it's maintainable by somebody later, right? And so we're using a different set of skills here, the programming logic skills. Okay, so I'm going to skip through some of this stuff. So each step as I'm programming, when I'm guided by zombies, is deliberate. We're choosing a behavior at a time. Usually there's only one choice. Well, I can't say there's only one choice. Usually there's limited choices to the simplest things to do next. And so when we're at this fork in the road and we've got two simple things to do, we try to find the simplest next small step to take, working our way towards something that's in mind. Usually we have something in mind that we're going towards. Okay, not mindless zombies, but choosing simple things to get us closer to that goal. One behavior at a time, cause and effect. Now this cause and effect thing is so profound. It took me, maybe 10 years of doing TDD, and then one day I woke up and thought, oh my gosh, TDD is way more than just getting tests to pass. And I can use TDD thinking even when I'm not writing tests. And so my website, which I put together back about, I guess it's been about 10 years now is when I started it. A friend of mine put together version 0 of my website, and then he got a regular consulting gig, and I was on my own with a Ruby on Rails website, and never having done anything with a web development or anything in Ruby, I was definitely disadvantaged at this point. So I want a new page on my website, and so I'd read the instructions on how to add a new page to the website. And the way it would go is I'd start in the morning about 9 o'clock, and I was in Florida. It was a nice warm day, sitting by the pool, my outside office, and write it, the code. I'd make all the changes. There's 5 steps in there to the changes. I'd go do it, and I'd hopefully, deploy it. Nobody's using this website yet, so I didn't know how to run it in my own machine. I was very, very naive about all this. I'd deploy it up to the cloud where it was running, and I would see that it would fail. No new web page and this long list of errors, and then I'd go read the instructions again and find something I think I got wrong and make a change, and still fails. I don't understand anything it's telling me. And this would last all day. And then about 5 o'clock, through the magic of total blind luck, the web page would come up and I'd go, oh, great. You earned yourself a beer. Go get a beer. And the next day, I would spend the whole day undoing the stuff that I did to get that page to come up that I shouldn't have done. Okay, so I was working in this batch mode, and it was just terrible. Now I can do that same thing in about 2 minutes because I've discovered the natural order to solve that problem. And so CircularBuffer, I think there are probably one or more natural orders to solve that problem in. Where we start. For the web page problem, the natural order is try to open the web page before you've done anything. What error message do you get? Well, you get a 404 error. Okay, I got a 404 error, great. Then you go into the part of your code that is first touched when you touch a new page, and that's the routes table. I had made an entry to the routes table. And then I get a different error. Yay, I changed the error message. And so I get a new error message. Now I know what that one is. It says there's no controller for this route. And so I add the controller. And then, of course, I get the next message, which is there's no controller function for this thing. And I add the controller function. And it says, well, there's no view for this thing you just created. Natural order to solve the problem. And I can do it much quicker and save myself a day of frustration of batch mode and a day of debugging it. You got to learn how to do that, of course. You've got to discover that natural order to solving that problem. Let's see. When I first put this presentation together, the 787 was in the news. I don't know, do any of you remember the 787 bug from probably 2015 or something like that? It goes something like this. The 787's power units would just shut down. Now, if the plane was in the air and the power units shut down, that would mean the plane's going to crash. It was only happening to their test airplane, which they had, in a hangar somewhere, and only when it was left powered on for too long. They tracked it down and they discovered, to the surprise of every embedded engineer, we all get to learn this once, which is if you're going to use an integer for counting clock ticks, eventually the integer is going to roll over. Okay? So you better be ready for when the integer rolls over, because it's going to go from the biggest amount of time to the smallest amount of time. And if you're not ready for that, bad things are going to happen. The number of, I think it was like the 32-bit integer rollover of a 10 millisecond or 100 millisecond counter took 248 days. And then the power unit's going to safe mode, which safe mode means shut off the power, which means crash the airplane. Okay, luckily that's 2 to the 31st centiseconds, hundredths of a second, as it turns out. So what could I have done? If I was a test-driven developer guided by zombies, and I had the delta t function, I'd probably, be trivial, right? So delta t of 0 is 0, and the delta t of 1,000 is 0. Okay. What if the delta t of 0, 1? Well, that would be 1. And if the delta t of 10 and 20 is 10, okay, I'm done. Except if you're guided by zombies. And then you're going to say, before you claim that you're done, you've got to say, what could go wrong here? What exceptional situations might there be? And now I might be thinking about uint32 max. Okay, so if it was 0 and int32 max, what would it say? And what if it was 1 and delta t of int32 max of 0? Okay, now I've got them reversed, right? So the biggest and the smallest, when that happens, does it give me the right answer, or do I have to go to safe mode because of integer underflow or whatever? Okay, so we can dream up the boundaries. If I can anticipate them, I can dream them up. So maybe the test-driven developer wouldn't have had that problem. All right, let's see. For some reason, I have a shameless plug right here, so I'll take the moment to give a shameless plug, but we still have some more time, so I've got some other stuff for you here, but let's see what my shameless plug is all about. So I teach people live over the web, but I don't do that very much. I used to travel a lot, about 100,000 miles a year, and I was trying to reduce that by doing remote delivered training, which I started about 10 years ago. And so I've got a pretty good system for doing that now, and you can see, kind of the virtual in-your-face kind of presentation style here and that sort of thing. But my website has evolved to support my training, and so what I do is like 3 half days, which is about a person's limit to being at a meeting like this. And about half the time that we're together, you're doing exercise. And then a little time before each training class, is time spent doing the prep work, which involves watching videos and such. This has evolved into a fully self-paced version of training, which individuals can take if they want, or teams can take together. And I've got a couple teams in there right now taking it together where they watch the videos together and do the exercises together. Or if you're a skilled test-driven developer already, and you wanted to lead a team through it, like one of your clients or something like that, you could use my system to facilitate leading someone through learning TDD. And so that's some of the stuff that I've been working on. I like doing this stuff, and I still feel like I'm on a mission because there are millions of embedded systems engineers, and not many of them are doing TDD. So there's still a need here for people to leave the Stone Age and come into, only 20-year-old practices instead of 50-year-old practices.